The Model Context Protocol, or MCP, is showing great potential for secure and efficient integration between AI models and external data sources. As organizations increasingly rely on AI-driven workflows, MCP offers a structured, context-aware approach to managing data and tool access. However, its adoption brings both significant benefits and new security challenges, requiring careful risk management and future-oriented strategies. Now that we understand some of the advantages that MCP brings to the table, let us examine the challenges and vulnerabilities they bring. Despite its strengths, MCP introduces several challenges and vulnerabilities that organizations must address. They include context injection and manipulation. Attackers may inject malicious context or manipulate the data exchanged between the MCP clients and servers, leading to incorrect or unauthorized actions by the AI system. Abuse of delegation mechanisms. If delegation chains are not tightly controlled, attackers can escalate privileges or impersonate authorized users, gaining access to sensitive systems. Non-deterministic policy evaluation. Inconsistent or unclear policy enforcement can result in unpredictable execution outcomes, undermining the reliability and trust. Audit invisibility. Insufficient or poorly structured logging can make it difficult to trace actions or investigate incidents, leaving organizations blind to certain attacks. Tool poisoning attacks. Compromised MCP servers can inject malicious instructions into tool descriptions, causing AI agents to perform unintended or harmful actions. Server compromise and credential harvesting. If an MCP server is breached, attackers may gain access to connected systems and sensitive data. Adversarial AI manipulation. MCP's reliance on context makes it susceptible to prompt injection and other adversarial tactics that manipulate AI behavior. To mitigate these risks, organizations should adopt a multi-layered, policy-driven security approach. Let us look at some of the basic steps to do so. Enforce context integrity validation by rigorously validating all context data exchanged between clients and servers, using cryptographic signatures and integrity checks to prevent tampering. Apply delegation chain tracking through monitoring and restricting delegation requests, ensuring that only authorized entities can pass privileges and that all delegation actions are auditable. Implement policy-bound execution enforcement by binding every action to a pre-evaluated policy, blocking any execution that lacks explicit authorization. Use structured and signed audit logging and generate comprehensive, tamper-resistant logs that link context, policy, and action, supporting forensic investigations and compliance audits. Apply zero trust principles and treat every component and connection as potentially untrusted, validating tool descriptions and server credentials continuously. Strategize risk adaptive controls and ensure real-time monitoring and anomaly detection to dynamically adjust enforcement based on observed behavior and risk scoring. Remember, emerging frameworks like MCP, Privileged Access Management, or PAM, are being developed specifically for MCP environments, offering context-aware access control, delegation verification, and risk-adapted enforcement as core capabilities. Looking ahead, MCP is poised to become a standard for secure, context-driven integration in AI and API ecosystem. Its adaptability and fine-grained control make it well-suited for increasingly complex, interconnected environments. As adoption grows, we can expect to see a more robust, automated security frameworks like MCP PAM emerge to address evolving threats and compliance requirements. However, the dynamic and decentralized nature of MCP means that security must remain a top priority. Ongoing research, standardization of efforts, and the development of secure by design architectures will be crucial to realizing MCP's full potential, while safeguarding against sophisticated attacks. MCP offers a powerful and flexible foundation for AI integration, but its success depends on proactive risk management, continuous security innovation, and a holistic approach to policy enforcement and auditability. By understanding and addressing its vulnerabilities, organizations can harness MCP's advantages while protecting their critical applications and data.